We now have our family of open weld heads for tubing and pipe, medium to thick wall applications. These weld heads are normally used for wire feed applications, but can also be used for thin wall autogenous welds. We will start first with this weld head. This model does not have any ABC or oscillation capabilities. What this weld head has is a torch, wire feed capabilities, a mechanical follower, and a set of clamps that will clamp on and off the piping. You also have a knob that will widen and close diameters for various sizes of pipe. The ability to open and close the clamp for various sizes allows the weld head to be used for more than just one size. Remember, this weld head will only give you a stringer bead weld process with and without wire and without ABC and oscillation, except for the mechanical follower that you can adjust. That is our weld head without ABC and oscillation. We come to a similar type weld head, but the main difference is that it has ABC and oscillation. The oscillation goes towards and away from the weld head, and the ABC goes up and down from the workpiece. The oscillation goes back and forth to allow you to feed wire into the weld puddle from side to side during the weld. Wire is fed into the torch and tungsten area during the weld. The clamping mechanism is the same as the weld head shown before and allows you to do several different sizes of pipe and tube, not just one size. For both these two weld heads, we have two different types of wire feeders for them. One of them can be connected to the top of the motor handle, called our integral wire feeder. And if you look behind me, you will see our standalone wire feeder. This holds a large wire spool and weight, which comes off the holder, goes through the wire feeding mechanism into the wire liner, going to the weld head's wire nozzle, and feeds the wire into the torch. There are several different sizes of wire that can be used with this type of system. This is generally used when you are further distance away from the wire to the weld head and do not want to change the wire as often. Our third series of open weld heads, actually there's more models than just this one, but I'm only going to show you one of them that we have. I am going to start from the back of the weld head quickly. It has the same clamping mechanisms that all the other weld heads have, so that you can do several different sizes of pipe or tube with one head, from smaller to larger pipe size ranges. This also allows for the faster usage of clamping and unclamping for the various size workpieces that you can weld with this weld head. Again, with this weld head there is a torch with tungsten, an oscillation motor side-to-side motion, and ABC up and down motion. ABC and oscillation are done automatically when programmed in the power supply. There is a wire feed motor on the side of the ABC and oscillation motors, which feeds the wire from the spool to the wire nozzle. On the back of all the weld heads is the motor for the rotation capabilities. You can see that all the other rotation motors are located in the back of the weld heads of this series. Here again with our weld heads with the ABC and oscillation functions is our tungsten. Tungsten is sharpened, placed in the collet holder, and placed inside the torch body. The tungsten will drop below the gas cup through the gas lens and stick out about 2 to 3 millimeters below the cup in front of the wire nozzle, and then we will secure it in place while screwing the nut on top. Once it is secure, then you can see that the tungsten is close to the wire nozzle. Next, your clamps need to be able to open wide and close freely to fit various sizes of pipes needed to be welded. For the larger pipe ranges, of the weld head, you will remove the smaller clamping supports. However, since we are going to be welding smaller pipe, I will be placing the smaller pipe supports on the larger pipe clamps. The smaller pipe supports fit into the larger clamps quickly, and we use an Allen wrench to secure them so they will not fall out. After placing in the first set, we will place the second set on the other side. You can see now that we can weld a wider range of smaller diameter pipes. The pipe clamps again will have a range of diameters when you open and close them, not just one single size of tube or pipe. Again, here's our wire motor, and at the bottom of the wire motor is the wire feed roller's wheel assembly. This will push our wire from the spool through the wire liner to the wire nozzle beneath the tungsten in the welding process. I'm going to close our wire feed roller assembly, the pressure wheel. And then take the wire from our spool into the wire liner and feed the wire into the nozzle so we can weld with it during our welding process. I will open the wire spool, feeding a little wire out, then I will hold it, cut the wire, introduce the wire into the liner, and push it through the liner until it feeds through the wire feed mechanism and the wire nozzle beneath the tungsten. Once you have the wire through the nozzle, you can adjust the wire nozzle so that it is about 2 millimeters from the tip of the tungsten. You will then tighten the wire nozzle and clip the wire back towards the nozzle away from the tungsten. Now we are ready to weld. Now we will open the wire feed mechanism so that you can see the wire feeding through the wire roller. We will close the latch assembly, tighten it back down securely. Once it has been tightened, it will give you enough pressure on the wire to be fed and pushed through the nozzle into the weld zone. With our open weld heads for tube to tube and pipe to pipe of larger diameters and different wall thickness applications, it is very important, no matter what the material is you're going to weld, carbon steel, titanium, stainless steels, or others, that you will need to make sure that you prepare the pipe and joint correctly before welding. Make sure that you remove all lacquer from inside and outside diameters for about 1 inch. It does not matter the material to be welded, it needs to be cleaned. We are showing you a V-prep, which is one of the preps in the welding process. The better the preparation of the pipe before the weld, the better the weld afterwards. We have the weld head in the home position, so now we can place it on the pipe after opening the clamps. To close it on the correct outside diameter size of the pipe. Then slide the weld head towards the weld joint and secure down the clamps on the pipe. If you need to adjust the size, you use the knobs on the side of the head, making sure that the tungsten is close to the middle of the joint. We're going to line up the tungsten with the joint so that we can actually start the welding process. First, you check to see if the tungsten is aligned in the middle of the joint. Then see if it can go down all the way to where the pipes are tacked together. Since the tungsten is lined up correctly, we will wrap the cord around the pipe so that we can make a weld. That way, the weld will end up near the starting point at the top of the pipe. We're going to run first a simulation of the weld prior to the actual weld. Make sure that you are also using your grounding cable so that all of your processes work correctly. If we have it also programmed into our schedule for the weld head to return to the starting position after it completes the weld, it will return automatically. After the simulation, the weld head torch and cabling will return to the starting point automatically, rewrapping itself, preparing for the next welding process. We are now going to actually continue with an actual weld process. We will initiate the arc process by forming a weld puddle during the delay and continue welding the pipe on its root pass. While welding the root pass, we are showing you that during the welding process that we are both breaking down the wall of the pipe and adding wire into the weld puddle, reforming a stronger welded metal. This is taking two pieces of the metal joined together by heat and wire to make a stronger bond between them. The metal is too thick to do in a single pass, so we will weld it in various stages or passes. After the completion of the root pass, the weld head will automatically return to the starting position, which will be about 11 o'clock. Since the pipe is too thick for a single pass weld, we will do it in two passes. However, the pipe is thick enough that we can do it in two passes. The second pass is both a fill and cap pass combined. We are going to do a simulation of the weld so that you can see the oscillation of the weld head, the torch, and the wire movements. However, we will not be feeding wire during the simulation process. The simulation will only show the rotation and oscillation movements. Please watch the oscillation of the tungsten and torch from side to side while it is rotating around the joint. The weld head is almost finished with its weld and is going into its downslope to end the welding process. Once it finishes, the weld head will rewind back into the starting position and we will perform the actual weld of the fill and cap pass. Now we will weld the fill and cap pass. See the position of the tungsten in the joint and the wire entering towards the tungsten. After starting the weld process, we have an initial delay to form the weld puddle, after which the wire is introduced into the weld puddle through the wire nozzle. We are pulsing from high to low current while we are welding and feeding the wire into the weld puddle. This gives us the normal weld puddle or bead look with the weave. We are also oscillating from side to side as we are performing the fill and cap pass. Notice our oscillation is wider than the bevel from side to side so that we tie in both sides of the metal in the welding process. Weld is now complete, and the weld head is automatically returning to the starting position. The weld is completed with the fill and cap pass, and you can view the weld bead after it's finished.